Hi everyone, Bones and I'm back to continue talking about ecology. Okay, now today we're going to start talking about not about the ecosystem, not about how an organism makes up a population makes up a community makes up the ecosystem. We're not going to talk about that today. But you like how I threw in that review there? I hope you did. All right, today we're going to start talking about how the populations of organisms living in an environment are restricted. Why don't the populations just explode infinitely? I don't even know if that's a word, Bones. Infinitely. Okay. But why don't the numbers of animals living in an area, human beings living in an area, deer living in an area, fish living in an area just explode? Okay. And that's due to something called limiting factors. Limiting factors do exactly what they say. They are factors that limit the types and numbers of organisms that can live in an ecosystem. Okay. They restrict it. They prevent the population from totally exploding out of control. Okay, and that's what we're going to talk about today. What are some of these limiting factors? Now, our limiting factors are considered the abiotic and biotic factors that we talked about earlier. Abiotic being things in the environment that are not living that affect how much an organism can reproduce. And biotic factors are living factors that affect how much an organism can reproduce and survive. Okay, so limiting factors are simple. They are just anything in the environment that limits the population of a certain kind of organism. So, for instance, we have a graph here. We've got three types of fish. We've got a rainbow trout, we've got a yellow perch, and we got a largemouth bass. Now, they're all living in the same aquatic environment, same aquatic ecosystem. However, they grow at, or they grow, when we say grow, we mean the growth rate of their population, okay? Not how big they get, but how many there are, okay? And we can see that they each thrive in a different temperature. So as the seasons change, as the weather outside changes, okay, as the temperature of the lake that they're living in changes, temperature, abiotic factor, it limits who's able to reproduce and who tends not to. So you can see here, in colder temperatures, so we're talking more winter temperatures here, the rainbow trout has an advantage. The rainbow trout reproduces more than the other two types of fish. Okay, it reproduces the best in colder temperatures, more like winter. Okay, temperature being a abiotic limiting factor. All right. Now, as springtime rolls around and the temperatures start to warm up a little bit, you can see the population of rainbow trout decreases, but the population of yellow perch increases. So they're thriving in a little bit warmer of an environment, okay? More of a springtime environment. Largemouth bass, you can see, once it starts getting even warmer, their population starts to explode. So they like the warmer waters in this case. So maybe they're going to flourish more in the summertime. So temperature is an example of a limiting factor that limits the populations of these three different types of fish. Pretty interesting. So there's all those abiotic and biotic factors that we talked about in previous videos help limit the population that is here on Earth because there are a limited amount of resources. Okay, if we're in a big, large class with 30 kids in it, and I bring in one slice of pizza for us to all live on for a week, that's going to cause some challenges because there's not enough resources to go around. So the limiting factors are really the resources in your environment that either allow you to reproduce a lot more or limit your reproduction for a certain time frame. Okay, so that's one example of an abiotic factor. Now, eventually what happens is an environment will reach something called its carrying capacity. Okay, carrying capacity is represented by this blue line right here. Now, the carrying capacity of an environment is the maximum number of organisms that can be supported by the ecosystem. That's all using all of the resources of the environment. This is the maximum number of organisms that can live, like the moose here. Okay, we see the moose population here has a carrying capacity of about 1.6, 1.7 million moose in a certain area. Now, what happens to the moose population? Because this is not just a nice, pretty straight line here. You see this purple line, which involves the actual moose population going up and down. Okay, so what happens is there are plenty of resources for the moose to continue to reproduce and live. So they reproduce, and they use the resources, and everybody's happy. Eventually, resources run out, okay? Eventually, the refrigerator goes empty, all right? And you have to restock it. So what happens is the environment is when those resources, whether it's food, whether it's living space, whether it's mates, any of those factors that we've talked about previously, okay, start to disappear, okay, the population will start to die off. Okay, so you can see here, they reproduce. The environment cannot maintain this many moose anymore, and so they start to die off and they go back below the carrying capacity. But then guess what happens? Guess, Bones, guess. That's right, Bones, they start to reproduce again. Because they're below their carrying capacity, that means there's available resources for the moose to be able to start reproducing again. It's like your fridge is restocked with food. Resources, let's go eat. Okay, so the moose start to reproduce again until their refrigerator is bare. There's no more resources for them. There's no more living space. There's no more food for them to eat. There's no more mates for them to mate with. So they start to die off and they go back below the carrying capacity. But then guess what happens, Bones? It happens again. Go ahead. What happens to the population? It goes back up. That's right. It goes back up. So when the resources are available again, all right, the moose start to reproduce, and they go above their carrying capacity. And it goes like this on and on forever. So the carrying capacity is the maximum number of organisms that can be supported by the ecosystem that they're living in. Okay? And this is all based on the limiting factors in their area. So take a look at this. Here's a big moose. How do you think the moose got that big? You think there are plenty of resources, Bones? There are. There is plenty of resources. Nobody's messing with this moose. It eats what it wants to eat. It moves where it wants to move. Okay? All of that stuff. This guy is not competing with anybody. He's playing on a game where he has an unfair advantage here. He is the man, the biggest moose I have ever seen. So this is because, in all seriousness now, because he has unlimited resources in the area that he's living in. If he did not have those resources, he would not get this big. Here's an example now of a biotic factor that affects populations. Okay, so we have a bobcat here, or a lynx. I believe it's a lynx, and a rabbit, and the green is the rabbit, and the red is the bobcat. And so we can see how they affect each other based on predation, a biotic factor here. So we can see here the population of the rabbit goes up higher. Okay, but the population of the bobcat goes down. But now all of a sudden, the bobcat realizes, wait, I've got stuff to eat. So his population starts to go up. Guess what happens? The population of the rabbit goes down. So now there's nothing for the bobcat to eat, so his population goes down. Guess what happens to the rabbits? Their population goes up. They realize that there's more food to eat now. Again, biotic limiting factor. Population of the rabbits goes up. Bobcat realizes it's time to eat. Fridge is full. His population starts to go up. As they're eating, guess what's happening? The population of rabbit goes down. All of a sudden, bobcats start to starve. Their population goes down. Now their population of the bobcat is down. What happens to the rabbit population? It goes back up. Time to eat. Bobcat starts to eat the rabbit. Rabbit population goes down. And this goes on over and over. So you can see it's like a delayed effect. Rabbit population goes up. Bobcat population goes up. Rabbit population goes down because they're being eaten by the bobcat. Then the bobcat population goes back down. And this happens over and over again. Okay, it's not a straight line with the carrying capacity, but populations tend to fluctuate, and they just kind of go like this based on what limiting factors or limiting resources there are in their ecosystem, in their environment, and their ability to survive and reproduce. Okay, so again, limiting factors, both biotic, which are living limiting factors, and abiotic, non-living limiting factors, affect population growth of every single organism out there, including plants. Plants, okay? If you have a rainy season, they're going to flourish and continue to grow. If you go through some time of drought, they're going to die off. Again, it's a limiting factor affecting a plant's ability to either grow or die. Okay? Hope you enjoyed learning about limiting factors.